Oh, time for next session. It's going to be Beyond Beauty, JavaFX, Parallax, Touch, Raspberry Pi, Gyroscopes, and much more by Angela Caicedo.
Thank you very much. Good morning, everybody. First of all, let me apologize for my sexy voice. I just came literally from Brazil. We were having a big event happening, Java Campus Party, and I think my body didn't take it very well, coming from 34 to 36 degrees to 0. So I do apologize if you attended to. I see familiar faces that went to our hands-on lab of the Raspberry Pi. Believe me, this is way better than 2 days ago. So once again, I'm really sorry, and I hope at least I have voice. If no, I have a backup. My boss is sitting in the back, so if I lose my voice on the way, he will be happy to jump on a stage and help us, so we should be good. Okay, so the talk for today. So I've been playing with the Raspberry Pi for a while, and I really like it because it's just so much fun you can have with it. It's just every time you get something new and I'm going to connect this and do something different, and I just love it. It's a really powerful little computer that you can have a lot of fun. Now we can have actually both embedded and Java ME embedded. So I started, every time I finish a demo, I start thinking about the next one. So I start thinking, okay, what can I do that could be interesting for embedded devices? And to be honest, I like when things looks good. So I'm always thinking about beautiful user interfaces, wow user interfaces. But when you're in embedded devices, you have a very constrained devices, the resolution might not be very good, so you have some constraints. So a lot of questions come into my mind. Okay, a very nice UI and a very emerging system could be a 3D environment. Not so good for embedded. What can I do that provide user immersion in the UI without costing me a lot? So that was my first thought. Okay, what can I build interesting for the user kind of interact with the environment without being costly for embedded devices. So once I have that idea, I say, okay, what platform should I use? Should I use SE embedded or should I use ME embedded? So as I mentioned, both of them will run on the Raspberry Pi. But some of them have some APIs. For example, if you talk about SE, you have JavaFX. So I've been a JavaFX evangelist for a while. I love JavaFX. I mean, creating a user interface is easy. It's a couple of clicks, and you can do really wow factors. But on Java SE, we do not have a good set of APIs to talk to peripherals. So that's like, I really want to include some sensors. I really want to get some positioning information of the device so I can apply that position to the user interface. So I'm like, okay, so I do have FX, I do not have accessibility to peripherals, knowing the platform itself. ME, and the other way, is come with what we call the Device Access API. It's a set of APIs that allow you to very easily connect to peripherals. So in my point of deciding which one to go with, I ended up using Java SE embedded because the UI part for me was more important. The good news is the Device Access APIs that is now on Java ME embedded, we're thinking into adding that in the future for Java SE embedded. So that's going to be solved, hopefully. Okay, and there are options. I start Googling and find some APIs that are Pi for Java that actually provide me with access to the peripherals. So I could actually work around the peripheral issue, still have my UI, bring on a lot of sensors, and have a nice UI on embedded and constrained devices. So this is actually what this talk is about. What do I encounter as I create my demo? Because we always think, I'm a software engineer. I'm not a hardware person. I like playing with toys. I'm not a hardware person, so it might take me longer than I expected. And things that I expect to connect things and the things work, but that's not normally not the case. So this is what the talk is about, telling you my story about how this happened, what are the issues that I have, and what was the result. Again, the reason of this talk, have a nice UI. Again, it's constrained devices, maybe solution like 3D, we're out of questions in my case. I know you can really run really good 3D applications on the Raspberry Pi, and we have shown that on a Java one in the previous year. But again, I'm just thinking more in general, embedded devices are constrained, so I want to keep 3D out of the question. I wanted to get user positioning, so I actually end up using both a gyroscope and an accelerometer, and I'm going to talk about it a little bit as we move on. FX, great solution for user interfaces. I want to create animation. I want to have touch support. I needed threads, so multi-threading was also another factor that why I choose Java and Java SE in this case for embedded. Because as you know, I need to have a separate thread for my user interface, but I need to have a back thread that is actually listening for the sensor information. So that part for me, having multi-threading was really important. So the agenda for today, so I'm just gonna give you like one picture and one slide about the Raspberry Pi. I think the Raspberry Pi has been around for a while, that it doesn't need any introduction anymore. Protocol that I use, I2C. The only reason, to be honest, is I just didn't play with it before. So I always think like, okay, what I haven't done that I should play with. So the only reason why I went for I2C was that. But what I found is really exciting to find all the latest and coolest, most of the devices support I2C. So for example, I found the Wii, the Motion Plus is actually using I2C. So I don't know if I can really tell my boss that I need a Wii for work and I can just take it apart and connect it to my Raspberry Pi. But again, I mean, it's just using I2C protocol. So in theory, I can just connect it and really have a very accurate positioning. I found also that could be maybe my next project. There is, the polar heart rate monitor. There is also a device that allows you to get the reading from the sensor, and it's also using I2C. So I can get the heart rate monitor reading from my polar sensor into my Raspberry Pi really easily. So it's like a lot of fun that you can really have using this. Enabling I2C on the Pi. So when you get the Pi and you get basic documentation, it says I2C and SPI enable. Cool. Well, you plug things, nothing works. And I found out that there is a blacklist in the Raspberry Pi. If you are in that blacklist, you do not work. And guess who was in the blacklist? I2C. So there was a couple of things that I had to do to be able to enable I2C on the Raspberry Pi. No rocket science, but it's still time-consuming things that you do not expect, or at least I didn't expect to find. The hardware that I use, I will talk a little bit about this MPU 599150. It was a little bit more expensive because normally sensors are like $5, $7. This was around $50, but it was really worth it because it has a lot of things in the same device. So I have an accelerometer, a gyroscope, a compass, I have a temperature sensor all in one chip. So I think it was worth it just to have it and use it. Chalkboard electronic, so I did use a screen. So what I end up doing is a homemade tablet. And this is actually what I have here. It's shiny, it's not metal, it's paper, okay? And on the back, I have my Raspberry Pi. And I have the sensors that I'm going to talk, and I think the result is actually pretty neat, especially when you have my 5-year-old daughter. I have to admit, she loved the iPad, and I love the iPad. When you have to go on a plane for 10 hours, I wouldn't jump without an iPad. So anyway, so when she saw this, it was like, oh, mommy, can I see Mickey Mouse on there? I'm like, no, you don't touch it. It's my work. So anyway, I mean, given that, like, oh, she thinks this is a real iPad, it makes my day. So it's a very cool device, handmade, got a couple of, it has Scotch tape and, really, really homemade, shiny tablet. And then the screen that I used was a chalkboard electronic screen, 10 inches. They also advertised the 7 inches. I'm trying to get one. I think it's still not ready yet. They're a little bit back on that. Not very expensive, around $150, but if you think about the price of the Raspberry Pis itself, it's very expensive. What it was worse in that part was the shipping. They're actually based in Malaysia, so at least shipping to US was like $50. So, but again, it's a great solution. I actually find that I'm going to try a very tiny screen on Adafruit. You know Adafruit, the website? I just love it. I just go there to see how can I spend my boss's money. And it was tiny screen, and it's only like $50. It's not, the resolution is not very high. It's like 320 by 240, but still, I mean, with a simplified UI, you can do a lot of cool stuff. So maybe next time I will try that one. Then I talk about the libraries. Again, I2C, we're going to be using Pi4Java in this case. Hopefully next time that I do a talk, I will be using the device access APIs on Java SE. Principles that I use. So what I wanted to do is to have kind of give the user the idea of the immersion into the environment as he moves the iPad, kind of positioning the UI depending on how the user flips the screen, right? So for principles, so I use a Parallax, and I'm going to talk a little bit about Parallax, and it's nothing new. It's been around for very long. It's been used in game development for a while, so just talking about that. And then the JavaFX implementation, very little. We talk about key points for how JavaFX make my life easier in this case. Okay, so the Raspberry Pi, big picture, everybody knows about it. I love it. The important thing here to notice is we have a set of pins that we can see there, and that's where you actually end up connecting things. So the Raspberry Pi has GPIO access. You can do SPI, I2C. You get voltage, you get ground for those pins. So it's actually give you a lot of things to play with. And what is important then from the headers is support for this. Libraries will, device access API support all of them, and in the case of today talk, the Pi4Java also have a wide support for this. Just to note on the Java specification for the Raspberry Pi, so on an ARM version 6, what happens is we do not expect to have hard floating points. What it means is normally the hardware itself does not support floating points. So the device ends up simulating floating points through software. Raspberry Pi is a little bit different because it does have support for hard floating point. So we do have a particular release for the Raspberry Pi that includes this support. So it's actually available, and it does support the hard floating point. So it will run much faster than software simulated floating point. Extending the Raspberry Pi. So as I mentioned, I had a lot of fun with the Raspberry Pi. And the only reason why I came with I2C was because I haven't done it before. So I have like a couple of slides that tell you a little bit the fun that I had before, trying to create a serial connection to the Raspberry Pi, reading from a USB, getting Gpios all working, and then finally moving into I2C. So again, lots and lots of great ideas. The very first test that we did is getting a console, serial console to the Raspberry Pi. And I think it's very important. Most of the embedded devices are headless, so we don't really have a user interface. So having a console that you see what's going on, it was really important. Tricky part when you try to adapt serial connection to the Raspberry Pi is the voltage. So what we're getting from the WART lines, the TTL lines, is just giving you 3.3 volts. And for the standard RS-232, we need 12. So we really need to bump up the 3 volts up to 12 volts so you can actually get the serial working. For this, very simple, we use a chip called MAX3232. It does the job for you, very straightforward, getting the pins from the Raspberry Pi and attaching to this board and then getting the console. So very straightforward project. We also test the USB interface. With the USB, we tried this little robot. And the idea with the USB, most of the drivers come for Windows, But if you connect a device and you can actually see it, you should be able to talk to it. You end up normally doing like a native code and then a GNI wrapper around it, and then finally you can actually use Java to connect to it. So again, if you recognize the device, see under dev bus USB to see if you see it, and then you should be able to go into some native code and GNI and finally Java. So this is like the interface for the robot arm, ended up being really simple, just open and close. We do have to do some synchronization, so we have to stop and kind of have a wait in between, but it was very straightforward. Gpios, so you have a lot of Gpio pins available for you to program, pretty much all the green ones, and the ones that are no greens, you can actually also use it as plain Gpios. Be careful, it's kind of tricky. This is the numbering, the numbers that the Raspberry Pi uses. So if you see the board, the tiny letters, it will tell you like the first one green is pin number 4, and the second is 17, 21, 23. For the libraries, the numbers are totally different. And again, I was trying to do my code and I was, okay, GPIO pin 17, true, nothing. 17 true, nothing, and ended up is actually 0 for the Pi for Java. So just make sure the numbers of the pins are different, but again, it's the only thing to be careful about. And connecting a motor to the GPIO lines, extremely simple too. Get the GPIO lines. In this case, we have 2 motors connected. All you need to provide, in this case, was ground and voltage, and we use L293 dual bridge for controlling the motors. So very simple. Again, cool stuff, but not cool enough for me. That's why I say, okay, what else I can do? Oh yes, when we did this project of the GPIO, we didn't have, I wasn't aware of the Pi for Java APIs, so we ended up doing also again low-level GNI, but that's not the case anymore, as I'm going to show you next. So, I2C on the Raspberry Pi. So again, I'm not a hardware person, so getting into something new, it really get me started from the beginning. What is the protocol about? How does it work? So this is what I found. It's very common. It's used for moving data simply and quickly in between devices. It uses a serial interface, and the good thing, so it has 2 buses. One bus is for data, and the other bus is for clock. So the way we transfer the data, we synchronize it with the clock. So what it is a synchronous kind of communication, different from the serial one, the RS233, that is asynchronous. So pretty much the master can be controlling how we communicate the data, how we exchange data. So this is a little bit how it looks like. So you have the 2 buses, and pretty much everybody hook up into the bus. What is really good is as long as the devices has different addresses, you can connect as many as you want. So that gives you a lot of flexibility, even though there are only 2, one bus for data and one bus for clock on the Raspberry Pi. You can connect multiple sensors on it as long as they have different different addresses. You normally require a pull-up resistor to connect any I2C. The good thing is the Raspberry Pi already has an internal pull-up resistor, so it's direct connection, so you don't need that external resistor anymore. It's using 7-bit addressing, and it has 2 roles. You're either a master or you're a slave. There is only one master at the time, and the master is the one that is generating the clock signals for the communication, okay? The slave simply receives that signal and responds to it if he is the one that is addressed to. And the beauty of the communication. I wanted to leave this in here. Not to scare you, because I think it really showed the power of the APIs, how they can actually hide all this information for you and you don't have to worry about this, but it's good to understand what's going on underneath. So pretty much in the communication, of course, there is a starting point of the communication and there is an end point for the communication. The start point happens when the clock is high, the line of the clock is high, and the master sends a high to low signal. That means we're going to start a conversation. The way the conversation ends, again, is with the clock line on high, the master send a signal low to high. Now, how you interchange data? Again, we're communicating 8-bit longs, so we communicate the 8-bit longs, and after that, we need to have an acknowledgement. Okay, so what we do again, the data interchange is also always happening with the clock line is high. So we transfer 1, 2, 3 until 8, and the last one, it will be the acknowledgement. Okay? Now, so you have your I2C device. The device has an address, okay? Inside that device, normally you have registries. So you need, for example, if I'm using, my device has a lot of registries, has way too many, and it took me forever to understand which one I needed, but anyway, that's a different story. But you have a bunch of registries. Sometimes you only need a couple of them. For example, temperature registry. Okay, I need that to be able to pull out the temperature reading. So you have to know the address of some registries, the one that, of course, are interested to you. So this is what I have here. What we need to do when we are doing this communication, the first time is who you're trying to address. So you already communicate with somebody, right? You already connect to your device, giving the address. Now you need to get some data or write some data from a particular registry of that device. This is where this comes to life. So first thing that you need to do is you need to provide the address of that registry that you want to talk to. And then if you're doing a reading or writing, okay? And again, acknowledgement. After that, you can actually read or write the data and acknowledgement, okay? The basic is everything is pretty much hidden for you with the API, but you still need to get these details to be able to access the information. Okay, so that was 3 slides for I2C, so now we are all expert on I2C, okay? Perfect. So now, enabling the I2C on the Raspberry Pi. Again, it was a big surprise for me that it was not enabled. I have no idea. So first thing, you need to go to etc modules and add those first 2 lines. And then there is some tools, I2C tools. I do find it very useful. Why? Because if you jump into the code right away and things doesn't work, you don't even know if the Raspberry Pi is able to see your device. So before you even move to the code, make sure the hardware is working properly. Make sure the OS can see that device. And this is what these I2C tools were very useful for. So again, it's not required, but I do encourage you to use them. Then the blacklist, beautiful blacklist. Under etc modprof.d, there is a raspberry-blacklist.conf, and you will find there I2C and SPI. So just remove or comment out those lines. Okay? Now, to see if it is enabled or not, so just try on the command line, do I2C detect. Normally it's bus number 1 if you're using the latest, really the latest model of the Raspberry Pi. If you're using model B, if you're still using model A, it will be bus number 0. Okay, if so, if 1 doesn't work, try 0. And what is this telling you? It's actually telling in this particular sample that I have 2 devices, 1 connected in address 40 and 1 connected in 70. So I know that the hardware is working. Now I can move into the Java code. Okay? Then just make sure everything is working. So go under /dev and you should see those entries. Okay? I did blog about it, so everything is in my blog. So if you want to go ahead at home and follow the steps, do not worry about, taking notes or anything. It's step by step on my blog, and I will give you at the end. Okay, the hardware. So that's the beauty chip that I use, 9150, and again, it's a 9-axis motion tracking device. Maybe more information that I really needed, but okay, perfect. It has both I2C and SPI protocol support, so I go for the I2C. It allows you, so you know, most of the chips already have an assigned address. This one doesn't. This one let the last bit, the least significant bit for you to set. So you can either turn it into 0 or 1 by grounded or not, put it into ground or not. So that allows you to have 2 devices of this one connected to the same bus. Okay? So we're gonna see there is the third one from the bottom up is AD0. So that's the least significant bit. So you can either turn it into 0 or 1 and have 2 devices into the same bus. So we have an accelerometer, we have a gyroscope, we have a compass, we have a thermometer sensor. And the good thing, the voltage range is 2.2 through 3.46, so it's perfect for the Raspberry Pi that gives us an average of 3.3. Okay, so why I needed accelerometer and a gyroscope. So what I wanted to do is I wanted to figure out if the user was tilting the device or not. So tilting the device, it could be tricky because what happened with the accelerometer reading. So accelerometer is reading actually acceleration against gravity. So we can actually find out the angle we're doing against gravity. Okay, so when you tilt it, if we are like this, I can actually measure this particular angle. Okay, I can find out that. With the gyroscope, when I'm measuring, is the rotation, the angular acceleration. So it would be good when I start rotating my screen, I can detect that. But once I stop, my reading is 0 from the gyroscope because there is no acceleration, there is no angular acceleration. This is when I need the reading from the accelerometer to find out if the device is flat or not. Because if the device is still with a slope, I should keep doing something because it's supposed to keep moving, okay? So that's why I actually need a combination of both. The gyroscope will just give me the rotation information, how fast you rotate, okay? And the accelerometer will tell me, okay, are you still tilting or you're flat? If you're flat, stop any movement. If you're tilting, do something. So that's why I actually needed both readings. How to connect everything. So again, it was very simple, one-to-one connectivity, not require any external pull-up resistors. As I say, the Raspberry Pi provide with that, so pretty much one-to-one. No rocket science here. Again, remember the ED0 for the least significant bit. So your address of the device will be either 68 or 69, depending on the last bit that you did. Okay, the screen. So this is how the screen looks like. I'm using the 10 inches one. If you're interested in the screen, this particular discount code will give you 10% off. And again, I mean, I think they are pretty nice screens. They are touch enabled, so you can actually have touch with Java. It's pretty good. It connects with HDMI, so it goes straight to your Raspberry Pi on the HDMI plug. Perfect, it worked out of the blue. They do have a little bit of instructions, a little bit of settings on the Raspberry Pi side, but pretty straightforward, nothing difficult. The wood work. So we always say if there is wood involved in your project and you have lights, good project. So there was lights and there was wood on the first attempt that I did. So this is when my first attempt was. I wanted to have everything in one flat area so I can flip it and have the reading from the accelerometer. Not very convenient for traveling, I have to say, but it did work for a while. So I have my Raspberry Pi, my screen. The screen has actually a light sensor, so make sure do not cover that one. So that will adjust the screen brightness depending on the ambient lights. It does have a touch sensor. It's kind of weird. You attach it to the USB of the Raspberry Pi. So if you want to have touch support, make sure the touch sensor goes to your Raspberry Pi via USB. And the funny thing is, the screen is the one that powers the Raspberry Pi. Okay? So the screen powers the Raspberry Pi, and then you finally power the screen. Okay? So that's pretty much the setting that I have. In this case, I have two sensors, so I was playing with first try, get something simple first working. So first I have just an accelerometer working. I use the ADX345, pretty similar to the one that is included in the MPU 9150. So I have the two devices there, so I can read from any of those. And then the evolution, this is pretty much the same thing, just looking a little better. So I just flip the device, put it underneath the Raspberry Pi. I also put underneath the sensor. So at the end, I have to adjust the code. So it was like inverted reading of the sensors, but pretty much the same. So software, okay. So again, we mentioned that we have the Pi for Java. Where did it come from, really? So, well, there is a native library that is called Wiring Pi. And this is actually written all in C, and it was inspired by Arduino wiring. It has access to to all the input and output in the Raspberry Pi. So again, has support for Gpio, I2C, SPI, word lines, everything. Okay, and then what the Pi for Java guys did, it just wrap it up, so we have a Java support to it. So I provide a bridge between those native libraries, Wiring Pi and Java for the Raspberry Pi. The guys that made it, they're very responsive. So I email them a couple of times. They help you right away with any question that you might have. Great guys, great community. There is a whole group of discussion about it going on for Pi for Java, so you can also get some help there. You can follow them on Twitter. I mean, it's a very good project, actually, and we have the pleasure to have them at Java 1 last year. Features pretty much everything. So pretty much for Gpio, you can export and unexport pin. You can configure your pin if it's going to be for input, for output, both. You can actually specify the edge detection if you're going to detect when it's falling or when it's coming up. You can add listeners so you can be notified when something happened in one of the pins. So pretty much everything you need for the Gpios. Also has RS-232 support for serial communication, SPI, I2, so pretty much everything you need for connecting any peripherals. Okay, so this is where it's available. You can get it, download it. Installation is just adding a package, so it's straightforward. It does come with a whole set of samples, so it's really great because you don't need to start from scratch. There are pretty much working samples there. For including into your project, just make sure the jar file is included in your class path. So that's the only thing. And yeah, you do need a root permission. So to get access to any peripheral, normally you do require root permissions. Okay, so installing, uninstalling, I mean, no rocket science. Again, demos you can build all demos are on the OPT Pi for Java samples. So let's see a little bit of the code. So if you remember the pins when I was mentioning the green ones, so see how the first green one here is 7 instead of 4, and how 17 now is 0. Okay, so again, numbering is totally different. The reason for them to have this number convention is sometimes the pins will change depending on the release. So they wanted to be, make sure that their API will work no matter what model of the Raspberry Pi you're using. So that's why the reason they didn't use the Raspberry Pi one. So here we're attaching a switch. So right now we're going to be reading from Gpio number 2, okay? So how do you create a code? So the way to create it, so you go to your factory, Gpio factory, and you get an instance of a Gpio controller. The Gpio controller is the one that allows you to create, in this case, we need a digital input pin. okay? Because we need to enter information into the pin. If it was an LED, it will be for output, okay? In this case, we have a switch, so it will be for digital input. Very basic information. The GPIO ID, in this case, remember, it was number 2, and how you're gonna listen to it. In this case, we're gonna have a pull down. You can have listeners, so when something happens, notify me. So you just simply say add listener, and you have one method that is handle GPIO pin digital state change event. So when something changes on that pin, this method is going to be called, and then you do whatever you want to do. Okay, so very simple. In here, we're not doing anything interesting really. We're just printing out the state of the pin and see if it's on and off. Okay. Make sure at the end you can actually shut down all the GPIO. So if you want a GPIO, if you want to terminate the controller, just make sure you shut it down. So very simple, few lines to have connection to your GPIO. In this case, just switch. Now, I2C. I2C is actually even easier to program. So first thing, you need to connect to the bus. So again, I2C factory, you get an instance, a static method, and you provide the bus that you want to connect to. Pretty much model B, as we mentioned, is bus number 1, so just connect to the bus. Then, once you have that bus, you get the device itself. So this is where the address of the device came into play. Okay, so in my case, I grounded that least significant bit, so it's 68, so I got my device. Now, okay, so I was so happy. I enabled I2C. I was able to have these 2 lines, get the bus and get the device. Okay, now I should be able to get some reading from the sensor. Guess what? Nothing. So again, it's like you ended up with a specification document for the MPU chip, like 300 pages that tell you everything about registries, and I'm totally lost. So what I find out after a couple of days of reading a documentation that I barely understand because it was all hardware related, I find out the chip comes in a sleep mode. So you have to wake him up. So unless you wake him up, he won't give you any reading. How clever is that? So if you don't do the next 2 lines, that is writing zeros in this particular 2 registry, you get no reading. It took me like a couple of days, seriously, to find out that I need those 2 lines to be able to run my code. So most of the time, you spend the time in something totally useless to have your project working. Anyway, again, this is particular for this device. Other devices, so for the hands-on lab, I was using a different device. It was a biometric sensor. So I'm like, oh, but I already did I2C. Come on, I already know everything about it. Well, guess what? To be able to read from the device, I always have in that particular chip, I have to write something to say, I'm going to read the temperature and then read the temperature. I'm going to read the temperature and then read the temperature. So they're all weird cases. You know, I expected that you say, hey, I'm going to be reading the temperature, and then I just read and read and read. But I didn't, the value never changed. I'm like, what's going on? Well, in that particular device, again, I'm going to read and then you read. I'm going to read and then you read. So everybody's different, and that's kind of the backside of this, that it's never like, oh, one single solution for everybody and I'm all set. Well, for that one, I didn't have to wake it up. So it's all different. So again, just make sure you understand if it's not working, try any wake up or any writing that you have to do before reading. Then some configuration information. So for my particular device, it was able to adjust the sensibility of the device. So think about it. I'm going to detect the flipping of the screen. That's a very small tilt. If you compare, for example, for a car wheel that is rotating really fast. So I was able to adjust the sensibility for my particular device. So that's what I'm doing in the next 2 lines, adding the sensibility of the gyroscope and accelerometer. Do not ask me what these values are for. I do not remember. But again, the document will tell you this bit is for this bit is for that. So these are the values that work for my particular case. Okay, and then very simple, you just read from the device. And now you got some information. How the reading works, so you can actually go to a particular registry. So remember, you have the device, and inside the device you have a bunch of registries where you can pull the data from. Luckily, the registry that I needed were all next to each other. So I have accelerometer data, temperature, and gyroscope data. So what you can do, you can position in the first registry and read all of them at once, okay? Or you can read one by one. I found it easier just to step in the first one and read all of them at once, okay? So that's what I'm doing. I'm stepping into the first registry, that was 3B. This is where I want the data that you're gonna read to be stored. So in this case, we're storing the data in this byte from so once you have the registry, what is the initial position for start reading? So I want it from the beginning to the end, okay? Why these numbers, 6, 2, and 6? So we have accelerometer, temperature, and gyroscope. Accelerometer has 3 coordinates, A, Y, and Z, and they're using 16 bits. So I needed to read 2 bytes to get the X value of the accelerometer. 2 bytes for the Y and 2 bytes for the Z. So that's why we have 6. Temperature is only 2, and then the gyroscope again 6. So that's why very handy. Once you have the byte array, it's better to create a data input string so you can actually get the values as int, short, unsigned bits, or whenever you need to read it, rather than just having to, otherwise you have to get the bits, and you have to, okay, if you're going to concatenate the most significant part with the least significant part, you will have to shift the bits. So it's a lot of, low-level programming for the bits. So I do encourage you to just get a data input string, give the bytes a rate, and then you can pull up the values as you want it, as an integer, unsigned int, shorts, or whatever. And then, once you get the reading, all I have to do is adjust it a little bit. In my case, for the sensibility of the sensor that I was using, I did have here to invert the value because I put the sensor upside down. So very, very, very simple thing. For the accelerometer reading, so I was a little curious. I was getting a lot of data, and I wanted to compare a little bit how much different does it make if I only have 1 coordinate, or 2 coordinates, or 3 coordinates. For the accelerometer, if I'm using just 1 reading, it will be assign the inverse sign. I don't know how you say in English. Excuse my English. If you're using 2 measurements, so what happens is when you have the device and you start tilting and you have 45 degrees, the reading gets a little not as good as the beginning. And so what we ended up having is the first rotation, the reading is very good in X, but once you get 45 degrees, the good readings that you're going to have is on Y coordinates. So when you have 2 angles, you can combine these 2 good readings and get a more, like a better measure of the tilting angle that you have. So you can end up combining those and using arc, tangent for this. To be honest with you, I use both, the simple using just 1 or combining for the tilting, and the difference wasn't that much. So either one was pretty accurate for me. So, and I really didn't need that exact positioning, so either one will work for me. And then for gyroscope, the only thing that I tried to do is try to see if I was flipping too fast, it would go really fast. I mean, my screen will move faster. And so I have a rotation fast peak factor. And a rotation peak is I try to rotate. So I need to detect, are you moving? I detect that, or you're moving really fast. So that's kind of the only 2 things that I did. Okay, I'm running out of time, 5 minutes. Okay, very quickly, the parallax effect. So it's very common. We see it every day when you're driving. So for example, here, if you're driving in the A position, you will see the tree on that's on this side. As you move on, the tree will be positioning here. So the tree is not moving, the mountain is not moving, it's your perspective against those two objects that will move. And that's the principle that we are actually trying to get here. There's a very nice document from Roman Cortez article that tells you how to get the vantage point, and that's where things move in relation to. In my case, I'm kind of using myself, so I didn't need to. And pretty much what you end up doing is a bunch of layers, and depending how close that layer is to that vantage point, it will move faster. So in my case, it will be me. So the closer the layer is to me, the fastest it will move. So for the UI, I got a bunch of layers. Thank you for Photoshop, otherwise I will be in big trouble. I put a lot of layers all together, and this is the UI that I end up. So let me show you what I have here with the 2 minutes left that I have. Let me see if I can get the, probably be able to get it. So why I have this camera here? Because if I try to show it to you, I will tilt the device and the screen will just wash it down. So it has to be flat to be able to manipulate it. Okay, so what I'm gonna do is let me just log in. Hopefully once I run it, I can just, I hate these little keyboards. They're very convenient. Oh, I'm in desktop, sorry. Oh. Thank you. The box. Okay, parallax effect. Okay, hopefully we're gonna have it just take a little bit of time while it load all the images, but hopefully. So what I have is a bunch of layers. The more layers you create, the better UI that you have. Still loading. Be patient. Once we have the cursor in the middle, yes. Okay. So things are working. So we have, so it looks like a flat image, but it is actually a bunch of layers. And hopefully as I start moving, come on. Okay, this is one of the demo things. Oh boy. I tried yesterday, I tried this morning, and it was working. Connect the device. Oh, we didn't have connection to the let me see. It's having issues getting to the I2C. Let's try one more time. Let's see. Configuring sensors, okay, I think we got a better one now. Okay, just give it a minute. We didn't get exception writing to the addresses, so we should be good, hopefully. That's one of the things about demos. No matter how many times you test it before your session, something might go wrong, always. Okay, hopefully, so if I start tilting, you can see how things just move. Different. And my idea was to hide things in the environment, so have like a treasure hidden, and unless you flip the things, you won't see it. And if I flip it down, you can actually see the layers. So creating the layers actually was the hardest part here, because it really needs, the more you create, the more realism that you give to your environment. Okay? So again, there are flat images, but it kind of gives you an idea of a different perspective. With that, I think I'm running out of time. I will take questions. If you want to come here and ask me questions, I'll be around. And thank you very much.